Good morning, students. Today we will perform remaining ED lab practicals on virtual lab. First you type virtual lab and then virtual lab electronics and communication. Choose electronics and communication branch and then choose basic electronic lab. Hello, आरू
यस मैम।
ये तो कर रहे हो ना गूगल पे?
हाँ मैम।
बेसिक इलेक्ट्रॉनिक लैब. Then this is the introduction about virtual lab. List of experiment. In list of experiment, we first perform diode, Zener diode as voltage regulator. This is the theory of Zener diode as voltage regulator. Objective: explain the function of Zener diode and explain Zener diode as voltage regulator. Function of Zener diode as voltage regulator. Here, function of Zener diode as voltage regulator is explained. Then Zener diode as voltage, there are two experiments: line regulation and load regulation. In line regulation, series resistance and load resistance are fixed, and we simply changes the value of input voltage and see the changes in output voltage, which is remain constant. In load regulation, input voltage is fixed and load resistance is changed. There is change in load resistance, input voltage is fixed, and then we see the changes in output voltage, which will remain same. This is a circuit diagram for line regulation and load regulation. In line regulation, there is a change in input voltage and we observe the output voltage. And in load regulation, this input voltage is constant and we change the value of RL and see the changes in output voltage. And then this is the procedure. Procedure of experiment is given in this section. Line regulation and load regulation. Then you go to the simulation and in simulation and click this Zener diode as a line regulator. Here. This is the circuit, Zener diode, and this is RL, load resistance. Here IL, and this is the voltage across RL. IL2 means current through load resistance and voltage across RL. Similarly, this measures the IS, source current, and this voltmeter measures this measures the current IZ, current through this zener diode, and this is the voltage, constant voltage source or DC battery. And in this experiment, instructions is given: set the zener voltage Vz is equal to 5.1. 5 point. This is the zener voltage, and if you set this 5.1, 5.1. Vz is set to the value 5.1. Series resistance. Series resistance is set to 1 kilo ohm and load resistance is set to 2 kilo ohm. Series resistance is set to 1 kilo ohm. Rs is set to 1 kilo ohm and RL is set to 2 kilo ohm. Okay. Then vary the DC voltage from 0 to 20 volt. This voltage 0.6 volt, and then this reading is add to the table. Here you will see the table. Unregulated power supply is 0.6. Load current IL. Load current IL is 2.55. Zener IZ is 0 and regulated output voltage is 0.6. Then change the value of Vz and add to the table. Second reading is added in this table. Then change the value of DC voltage, and here you get the output voltage is 5.1. Means in this, at this stage, this Zener diode acts as a voltage regulator, and add this reading to the table. Then fourth reading, add to the table. Then change the value and add this to the table. Similarly, you change the value of input voltage and add to the table. Then you click the plot and you get the plot of this voltage regulator. Clear? Aru? Aru?
मैम आपकी आवाज अटक अटक के आ रही है।
Arunama?
हेलो
Experiment is clear?
मैम आपकी आवाज अटक अटक के आ रही है, इसलिए सुन नहीं रही सही से।
Vikas? Next experiment is Zener diode as load regulator. This is the circuit. This is the circuit, and in load regulation, you keep you will keep the value of DC voltage constant and change the value of RL and see the effect in the output voltage. Set the DC voltage to 6 volt. RS to 100 volt, 100 volt. Then VZ, set VZ to 5.1, and then change the load resistance and add to the table. Then change the value of RL, add to the table. Next value of RL, add to the table. Similarly, change the value of RL and add all the reading to the table. And then plot all these readings in the graph. Arunama,
Hello.
hello.
Yes, ma'am.
Aru,
Hello. Hello. Hello.
this is the circuit of Zener diode as voltage regulator. Then next practical is BJT common emitter characteristic. BJT, go to the simulation part and then click BJT input characteristic. This is the common emitter configuration. Emitter is at ground, base is at the input, and collector and emitter is at output. When transistor act as when this is NPN transistor and this act as an amplifier, it means that base emitter junction is forward bias, collector emitter junction is reverse bias. Clear? And to draw the input characteristic, we draw a characteristic between input current IB and input voltage VBE at constant VCE, at constant output voltage VCE. So in this case, initially set rheostat RH1 at 1 ohm and rheostat RH2 at 1 ohm, and then set the collector emitter voltage VCE to 1 volt by adjusting rheostat RH2. So set rheostat at 1 ohm Then rehearsal at 2 ohm. Here value of VC is 0.1. So by adjusting RH2, the value of VC in this case is 1 volt. Then you change the value of then change then change the value of base emitter voltage by adjusting rehearsal RH1. Yes, and add to the table. In this case, base emitter voltage is 0.24 and base current is 2.818. Here, then you change RH rehearsal first rehearsal RH1 and add to the reading to the table. In this case, value of IB is 3.6 and value of VB is 0.42. Next, add to the table. Next, add to the table. Then change the value of IB and VB and add to the table. Similarly, you change the value of input current, input voltage, and all the readings are added in this table. Then plot these readings and you get the input characteristic of common emitter transistor. Then you set this value of VC is 2 volt and similarly by changing the value of RH1 you plot the input characteristic of BJT amplifier. BJT output characteristic. In output characteristic, we draw a characteristic between output current and output voltage when input current is constant. Input current is base current, so in this case we kept we will kept the input current at constant value and draw the characteristic between IC and collector to emitter voltage VCE. Here initially set rehearsed RH1 at 1 ohm and rehearsed RH2 at 1 ohm and set the base current 15 microampere by adjusting RH1 1 ohm 1 ohm and then by adjusting this rehearsal set the value of base current 15.35 microampere and then change the value of RH2. Then vary the VCE by adjusting the rehearsal RH2. This and add these readings to the table. Change the value of RH2 and add readings to the table. And then plot all these readings. Similarly, next reading, we can set the value of IB at 20 microampere and change the value of rheostat RH2 and plot the characteristic between output current and output voltage. Because next experiment is input characteristic of common base configuration. This is common base configuration because base is at ground. Here emitter current IE is input current, input voltage is VBE, output current is IC and output voltage is VCB. Input characteristic is drawn between input current and input voltage and output characteristic is drawn between output current and output voltage. First we draw input characteristic. Set Initially set RH1 at 1 ohm and RH2 at 1 ohm. Then set common base VCB at 1 volt by adjusting rheostat RH2 and common base VBE is changed by adjusting R. So first set RH1 at 1 ohm and RH2 1 ohm. Then adjust this VCB at 1 volt by adjusting this resistor RH2. 1.2. This is 1.2 volt and then by changing RH1 we change the value of VBE and add all these two readings to the table. Then by changing RH1 and add the reading of IE and VBE to the table. Next reading of IE and VB is added to the table. Clear? Simply by changing RH1, you change the value of VBE and IE and add to the table and then plot, and you get the you find out the input characteristic of common base configuration. Similarly, you can draw the input characteristic by setting VCB at 2 volt, 3 volt, 4 volt. Here is the common base output characteristic. In common base output characteristic, initially set voltage RH1 at 1 ohm, RH2 at 1 ohm, and set the emitter current IE 1 milliampere by adjusting the velocity RH1. Set RH1, yes, and then set the emitter current IE at 1 milliampere. The value of IE at this point is 0.76. So set this emitter current at 1.1 milliampere. Then change the rheostat R2 and you get the value of IC and VCB and add these readings to the table. Then you change the value of RH2 and add the reading of VCB and IC to the table. Third reading, similarly for fourth reading is added to the table. Fifth reading is added to the table and sixth reading is added to the table. Then you plot the output characteristic of CB or common base amplifier. You can plot the next output characteristic by setting the value of IE is 2 milliampere or 3 milliampere. Clear? Arunama, hello.
Hello, yes, ma'am.
Ranjit, Vikas,
Yes, ma'am.
हेलो. हाँ, ये तुम्हारा कंप्लीट हो गया. ईडी लैब। तो अब इसको जो है कंप्लीट, इसको जो है इसकी फाइल बना लो और कब सबमिट करोगे ये बताओ। रंजीत, हेलो रंजीत,
यस मैम। हेलो।
ये तुम्हारा ईडी लैब कंप्लीट हो गया है। अब इसको जो है कंप्लीट करके 10 डेज में उन्हें कॉपीज जो है फाइल सबमिट करो।